So let's just start with a simple example, right? So I'm using the data that I got from the World Value Survey. Suppose we said, is religion important in your life? Okay, so it will assume the value of 1 if it is important, and it will get a value of 0 if the individual say it is not important. Okay, so this would be, our y value. Okay, the dependent variable y. So the explanatory variables, all right, just to keep it simple, we will just use two, right? One is a quantitative variable, the number of children, okay, the individual has, and gender, right? Gender, we use a dummy variable, male, right? Where it is equal to 1 if the individual is a male and 0 otherwise, meaning if the individual is a female. So we want to know, number 1, all right, if the person has more children, would he or she thinks that religion is important in his or her life? Okay, and also we want to know, is there a difference, okay, between the two gender, between male and female, in terms of religion being important in their life? Okay, so what would be the theory, and therefore what would be the expectations? Okay, so some theory says when you have a family, all right, so when you have more children, it your spiritual life becomes more important. Therefore, religion becomes more important in a person's life. Okay, according to theory, for instance. And people, some studies have shown that females are more religious than males, and but there are also some studies that shows otherwise. So we just want to use this example, right, just to demonstrate to you about probability models, the LPM, the logistic model, as well as the probit. So the data that we use, right, which is given to you, is religion logit probit, all right? So you can look at your data and you can also do the same, okay? So what you do is, if you use eViews, okay, you will do the same thing, all right, where you will have your religion, all right, your dependent variable first, and then your explanatory variable, your number of child and male, all right, and your C, and you can choose, all right, the method of estimation is binary. Okay, is binary. So when you click on binary, you will find that you can either choose probit, logit, or extreme value. Okay, so for now we're just talking about probit or logit. Okay, so once you click on probit or logit, and when you have okay, all right, so as we said before here, okay, this is your binary. Okay, so you will get this window, then you can say okay. All right, so when you say okay, you will get, if you choose a probit, you will get this one. If you choose logit, you will get this one. And this is just using the least squares method. All right, so here, as you said, this is using least squares, this is for logit, and this is for probit. So number one, all right, we want to look at the significance of these explanatory variables, the usual way of doing it. So you will find that, all right, this is a positive number and it is significant if you use the LPM. Okay, so you find that, all right, the more children, okay, a person has, the more the higher is the probability that the person says that religion is important. Okay, and similar results you obtain for the logit model, all right, where you find that this is positive and you have a small p-value. The same thing over here with a p-value which is very small, right? So they're all significant at 5% or even 1%. However, for gender, you find that this is, although this is negative, okay, but it is not significant. So we can say that there is no difference between male and female in terms of importance of religion. Okay, so no one gender feels that religion is more important compared to the other group. Okay, so for the linear regression, no, sorry, the linear probability model, you can interpret, all right, the beta directly. So you can say, as you increase the number of children by one, the probability that a person says that religion is important will increase by 0.008. Okay. However, you cannot interpret, all right, this value for probit as well as logit, okay, because you know that the marginal effect is not constant. Okay, so before we go back to this one, all right, this is the test for overall significance. So remember for the LPM, this is the usual F statistic that you will be using. So you find that the p-value is small, right? So there is, at least one of these variables significantly affect the probability that a person saying religion is important. Over here also, for the logit model, you find that there is overall significance. Similarly, for probit model, you find that there is overall significance. Okay, so if you want to check for your R squared or your count R squared, okay, so you can go in eViews, all right, once you have your output, okay, then you go under view, and then you will choose expectation prediction evaluation, and then they will ask you success is probably greater than 0.5, and you will say okay. All right, so when you do that, all right, you can actually get this is part of the table that it is given. So over here, if you want to see your count R squared, you find that 97, according to the model, right, the correct predictions is about 97.44 if you use logit. Similarly, if you use for probit. Okay, so if you want to find, all right, the z value as well as the probability values, okay, you know that the number will be different for different observations because this z depends on what the x values are. So you don't need to compute it yourself. You can go under eViews, under proc, all right, and then you will choose forecast, fitted prop, and index. Okay, so when you do that, right, you can either, if you want the probability, you can click on this one. If you want the index, all right, which is your z, you can also click on that. Okay, so if we click on probability, the forecast name is religion F, all right, or if you don't like it, you can just change it to some other thing. All right, so when you say okay, right, so this is, as we said before, this is index, so it's up to you. Okay, and when you say okay, all right, automatically, all right, they will create this religion F, okay, a new series in your data file. Okay, and you can see that this is what the values are. Okay, so the forecast, as we said before when we were looking at that table, this is 0.986, so which means that we will classify this as 1. This one, there is missing data. This one will classify as 1, 1, 1, 1, and so on. Okay, so you will find over here, then you can actually compute that count R squared. Okay, so here, as we said. All right, now we can compute the marginal effects as well as differences across groups. Okay, so if you want to get the details of it, you can look at the Excel file, which I will give it to you. The Excel file, which is called religion, logit, probit, marginal effects, on how I computed these values. Okay, so again, these are just your estimated coefficient values, okay, from the table that we had before. But this one, we need to compute, all right, the marginal effect. Now, if you remember the marginal effect for the for the number of child is equals to the beta, all right, the beta hat that you got times by the probability of y equals to 1 and probability of y equals to 0. Right? So when you do that and you compute this at the mean. Okay, so you will get this for the logit, a similar way of doing it for your probit. Okay, and for the dummy variable, right? So you can again compute as what we do the calculations before. Compute, the probability for y equals to 1 when your m male equals to 1 and your male equals to 0, right? And you compute it at the mean values. Okay, so for more details, which I'm not going to go over, you can look at the Excel file on how I get these values. Okay, so you know that this this is not a significant variable. If you also do it for logit and probit, the difference here is very small. All right, so the probability for male and female is very small when we compute it at the mean.